to KSSM channel. I'm Madam Wong here. Formative Exercise 7.2. A gardener wants to plant hibiscus and roses on his plot of land of 300 square meter. He has at least 1,000 ringgit to buy the plants. A hibiscus plant costs 4 ringgit and it requires a land area of 0.4 square meter, while a rose plant costs 5 ringgit and it requires a land area of 0.3 square meter. The number of roses must exceed the number of hibiscus by at most 200. A. Other than x greater than equals to 0 and y greater than equals to 0, write 3 inequalities that satisfy all the above constraints if x represents the number of hibiscus plants and y represents the number of roses plants. So we'll first build the table. We have two information given on two plants, hibiscus plants and roses plants. And we have about the land and cost. Alright, so about the cost, the hibiscus plants cost 4 ringgit and it requires land of 0.4. Therefore, we have these two. And the rose plants cost 5 ringgit and it requires a land of 0.3 meter square, right? And the total number, about the land, okay, the total area is only 300 square meter. So the total plants that we use, the land, cannot be more than 300. So it must be less than and equals to 300. And then he has at least 1,000 ringgit to buy the plants. So we should have greater and equals to 1,000. So form up our inequalities. So the first one, from the land, 0.4 times x plus 0.3 times y should be less than and equals to 300. So make our number into integer. We make 4x plus 3y equals to 3,000. We times everything by 10. Number 2, about the cost. 4 times of x plus 5 times of y should be greater and equals to 1,000. Then the third one cannot get from table, but is from the last sentence. The number of roses, which is y, must exceed the number of hibiscus. So when we minus the hibiscus, x, by at most 200. So should be less than and equals to 200. There we get our third constraint. Alright. Then B. Using a scale of 2 cm to 100 trees on the x-axis and y-axis, draw and label the region R that satisfy all the inequalities in A. So we need to draw the graph. Basically, we need to draw 3 lines in the graph. So number 1, we need to draw 4x plus 3y equals to 3,000. So pick our x and y intercept. So the y-intercept should be 100. It should be 1,000. Alright. And when y equals to 0, then 3,000 divided by 4, it should be 750. Right? Then for second line, we need to draw 4x plus 5y equals to 1,000. Same thing, we choose our y-intercept and x-intercept. When x equals to 0, then 5y equals to 1,000, where 1y equals to 200. Okay. When y equals to 0, 4x equals to 1,000, so the 1,000 divided by 4, we get 250. Okay. And the third line will be y minus x equals to 200. Alright. So if we choose our x-intercept and y-intercept, we'll see we can get the y-intercept 200, but the x-intercept, when y equals to 0, x will be equals to negative 200, where our x and y should be greater and equals to 0. So we are not taking the negative values. So to try to get another point, alright, so in here, I will choose x equals to 200. Then I will choose the pair of y. I will get the pair of y from the calculation. So when x equals to 200, y should be equals to negative 200 move over, become 200 plus 200. So we get y equals to 400. So here is the graph. Alright, and from the inequalities, we want lesser. Okay, then second constraint, 4x plus 5y greater and equals to 1000 on top. And y minus x should be lesser and equals to 200. So lesser and equals to 200. So this is our region R. And we go for C. From the graph obtained in B, answer each of the following questions. Number 1. Find the maximum number of rose plants if the number of hibiscus plants is 300. So this is direct. We just need to find the maximum number of y when the x is 300. Alright, so we'll see. When the x is 300, then we get a range of y here, which is from 0 up to maximum 500. So the maximum y is 500. Then number 2, within a given period, each hibiscus and rose plants generates a profit of 350 and 240 respectively. Find the maximum profit of the gardener. So our objective function, okay, is about the profit. So k is 350 times x plus 240 times y. Then build our objective function. Okay, so we assume that k equals to 420, and from 420 equals to the 350x plus 240y, we get the y-intercept 175 and the x-intercept would be 120. Alright, so plot the 2 points, so we get this objective line here. Now we want to get the maximum profit of the gardener. So this objective line should be pushed, okay, and we put the second ruler here as our track. So we should push this orange line towards our region until the very end or very last point, okay, to get the maximum profit. Okay, so here we go. The very last point is stopped on 750 and 0. So this is different from the textbook. Alright, so the maximum profit here happens on 750 and 0. Therefore, our maximum profit will be 350 times 750 plus 240 times 0, and we get maximum profit of 2625. Alright, so you can see this answer is greater than the answer that the textbook gets. Alright, so this is the maximum profit. Next, question number 2. Okay, Mr. Malik allocates 3,000 to purchase X copies of science reference book and Y copies of mathematics reference book for school library. The average cost per copy of science reference books and maths reference books are 30 ringgit and 25 ringgit respectively. The number of science reference book purchased is at least 20 copies, and the number of mathematics reference book purchased is at least 10 copies more than the science reference book. So A, write down 3 linear inequality that satisfy all the given conditions other than x greater than equals to 0 and y greater than equals to 0. So from here, we don't build table because we can solve this one by one. Okay, so we have only one information about the cost, which is 30 times of x plus 25 times of y should be less than and equals to the 3,000 because Mr. Malik only allocates 3,000. So the money spent must be less than or at most, okay, must be less than or at the maximum you spend all the 3,000. So it should be less than and equals to 3,000. Then the second information or second constraint, the number of science reference book purchased, which is the x, is at least 20 copies. So the X greater than or equals to 20. And the number of max reference books purchased is at least 10 copies more than the science reference books. So mathematics reference book purchase at least, so greater than or equals to 10 copy more than the science reference book. So the science reference books has to plus another 10. So this is our third constraint. B. Using a scale of 2 cm for 20 copies of books on both axes, construct and label the region R that satisfy all the constraints. So we need to build 3 straight lines from these 3 inequalities. So the first one, 30x plus 20y equals to 3000. So again, we get the y-intercept when x equals to 0, 3000 divided by 25, we get 120. And the x-intercept when y equals to 0, 3000 divided by 30, we get 100. So later we will need this point. Second equation is just x equals to 20, so we don't build table. Then the third equation, y equals to x plus 10, and get the y-intercept when x equals to 0, my y equals to 10. Okay, so again, we don't choose x-intercept, okay, because we will get x equals to negative 10. So I'll choose another value of x, okay. Let's say we choose x equals to 60 here, then the y should be 60 plus 10, which is 70. There we get our graph. Alright, so 0, 120, and 100, 0. So make sure you have a long ruler, okay, if you want to use the intercept point. Alright, then second line, x equals to 20, so go for x-axis, look for 20, then we draw a vertical straight line and we get x equals to 20. Okay. Then when y equals to x plus 10, we have 0, 10, and 60, 70. 60, 70 is here. So you will see all the 3 lines here. And the shaded region, number 1, 30 plus 25x less than and equals to 3000. So for this line, we'll get the lower part of the line. When x greater than or equals to 20, so I will have to take the right hand side of the x equals to 20 so that it contains all the x values that is greater than 20. Third one, when the y greater than or equals to x plus 10. So look for the y equals to x plus 10 and we want the upper region. So we can see our R is inside the triangle. Then C, from the graph obtained in B, find the minimum cost to purchase the book. So what is the cost to purchase the book? It's been stated here, alright. So an average, we have 30 ringgit to purchase a science books and 25 ringgit to purchase the max reference book. Alright, so this is our objective function. So we don't need to draw any other line, okay. As the objective function, we can straight away use this. The line that we draw just now, 30x plus 25y equals to 3000, right? So we can use this as a reference line. And now we want to find the minimum cost to purchase the book. So our objective line should go to the very first point. So we'll go back downward to our region. Alright, so and we'll see it happens on 2030. So the minimum cost is 30 ringgit times 20 science reference book plus 25 ringgit times 30 max reference book, and we will have to spend minimum RM 1,350. Okay, number 3. A beverage factory produces 2 types of beverage, P and Q. To meet the consumer's demand, the factory must produce X liter of beverage P and Y liters of beverage Q. The production of beverage from the factory is based on the following constraint. Number 1, the total volume of beverage produced is not more than 7,000 liters. Number 2, the volume of beverage Q produced is not more than twice the volume of beverage P produced. And number 3, the volume of beverage Q produced is at least 1000 liters. A. Write 3 linear inequalities other than x greater than equals to y and x greater than equals to 0 and y greater than equals to 0, which satisfy all the constraints above. So number 1, the total volume of beverage produced is not more than 7,000 liters. So the x plus y liters, should be less than and equals to 7,000. Number 2, the volume of beverage Q produced is not more than twice the volume of beverage P produced. So the y must be less than and equals to 2 times of x. Number 3, the volume of beverage Q produced is at least 1000. So we only focus on beverage Q, which is y. So y must be greater and equals to 1000. B. By using a scale of 1 cm to 1000 liters on the x-axis and y-axis, construct and label the region R that satisfy all the above constraints. So we need to draw the 3 straight lines to get the region R. So number 1, x plus y equals to 7,000. We'll try to get our x-intercept and y-intercept. So we'll get y-intercept is 7,000 and x-intercept is 7,000 as well. Line number 2, y equals to 2x. So when we choose x-intercept, then we'll find that when x equals to 0, y will equals to 0. So we get 0, 0. So we got to choose another point other than 0, 0, which I choose 20. And my y will be double of the 20, which is 40. And the third line, only y equals to 1000. So we can draw our graph. Okay, 2 cm to 1000 liters. Alright. And we get this. The first line, 0, 7,000 and 7,000, 0. Okay. And then the second line, 0, 0, 2,000 and 4,000. Alright. So 2,000, 4,000. So we will get the 2 lines here. And the third line, y equals to 1000. This is the line. Alright. Then we need to shade the region R. Look for the A. When x plus y less than and equals to 7,000, x plus y equals to 7,000, I want the lower region of the straight line. Number 2, y less than and equals to 2x. So y equals to 2x, I want the lower region of this line. The third line, y greater and equals to 1000. So when this line is y equals to 1000, I want the value on top so that all the region above, okay, it covers all the y values that is greater than 1000. So this is our region R. Then C, based on the graph obtained in B, answer each of the following questions. Number 1, on a given day, the volume of beverage Q produced is 2000. Find the maximum volume of beverage P produced. So beverage Q produced is 2000 liters. Okay, so the y equals to 2000. I need to find the maximum Q. So look for the line. Okay, when y equals to 2000, our x value is from 1000 up to 5000. And we want the answer for maximum. So the maximum number of beverage Q produced is 5,000 liters. Alright. Then number 2, if the profits per liter of a beverage P and Q are 50 and 30 respectively, find the maximum total profit of the factory. So build up our objective function, k equals to 50 times x plus 30 times y. And then use a reference number to draw the objective function line. So when k equals to 150,000, okay, the x-intercept and y-intercept will be 3,000 and 5,000. Alright, then we'll push the objective function line and get the maximum point, which is 6,000 and 1,000. So this is our optimum point where the maximum profit happens equals to 50 times of 6,000 plus 30 times of 1,000. All right. So we have 300,000 plus 30,000, 330,000 ringgit Malaysia. The end. Thank you.